Okay, so for solving by completing the square, we first got to talk about what solving really means. So if I'm going to solve a quadratic, my favorite saying, if you can factor it, you should. Because so often on the hard problems in our class, it ends up coming down to factoring. So I have an x, and then if I can't factor it, I quadratic formula, right? Okay, but could this one factor? I'm sensing that it probably could because I could use a 6 and a 3 to make an 18. And that makes me think I could get a 3. So I'm going to go 6 and 3. And I just got to be careful where to put the negative now. I want the positive to win because I want the middle term to be positive. So I'm going to make that one positive. And I'm going to check for sure. Outside, inside. And then those make positive 6x and negative 3x. Yay, it worked. I solved it. So I got the answers. What does it mean to get the answers? It means the numbers that work when you stick them in. X equals 3 works, and x equals negative 6 works. They make zeros. They make roots. They're also the x-intercept. All right. So that's what it means to solve, is you get answers that will work in your equation. So what if it doesn't factor? You use the quadratic formula. This one wouldn't factor. So you'd use the quadratic formula. I've done that enough with you that I think we can pass on that one. Moving on. If I had to find the solutions to this, my first gut feeling says if you can factor it, you should. All right? And I see a 3 in everything, so I'd factor the 3 out. But does that factor? Can I get it factored again? Is there a way to make a 2 and a 1 into a 2? I don't think so. Can anybody factor it? If you found a way, please tell me now. Okay, I don't think this one factors. All right, so what do you think we should do? Well, given the context of what we've just been doing lately, do you think that we could do complete the square on this thing? Could we? Sure we could. Let's do the complete the square thing and factor out the 3 out of just the front part. 3 comes out of there. Bring this down. Half and square, half of 2 is 1, 1 squared is 1. But really it's going to have a value of 3. So I'm going to cancel it with a negative 3. What's the point, Mr. Server? Because now that's a weird looking square. Going to fix it. Now we can use the same process that we used before to solve it. Do you know what I'm talking about? What did we do last time when we had had one in vertex form? We started by adding something, so let's add something. What are we going to add?
9.
You add 9. What are you going to do next?
Divide by 3.
Divide by 3. Jameson. Next. Square root thing over both of them. Yes. Hope you remember the absolute values. Smiley in the back row. Divide it up into 2. Nice. Now, if you had wanted, you could have put the negative on the other side. But either way works. And I actually like it the way you did it because both of them are on the square root now. The one's positive square root, one's a negative square root, so that later we're going to have plus and minus the square root of 3 in our answer, right? All right. Gavin. Solve by adding what to everything? Let's just make one big answer, Gavin.
X equals 1 plus or minus the square root of 3.
That's it. And I'm glad you said x equals, because that reminds us what we've actually got. We've got the two things that would make this equation 0. Those are the zeros. Are they real places? Yes, because there's no I. We never had a square root of a negative. They are real places on the x-axis. What is 1 plus the square root of 3? I don't know. Well, let's say the square root of 3 is like 1.6 or something. 1 plus 1.6 is like 2.6. That's a place. It is kind of weird place because it's a square root that goes on forever and never repeats. Just to clarify, that's called a irrational number, because it goes on forever and never repeats. So you can never know exactly where that thing is, which is kind of weird. You could put it on a dot on a number line and say, well, it's pretty much there. Okay, so what was the process there? We had this equation. First, we looked to see if we could just factor to solve it. But we couldn't factor it all the way, because when we took out the 3 out of everything, it didn't work. Then you can try taking the 3 out of just the front two things, rewrite it in vertex form, and then solve it from there. All right, so that's the moral of the story on this one. Caught that. Everybody try solving this one. If you can factor it, you should, but this is even set equal to 12. So I think even more reason why we shouldn't try to set it equal to 0 and then refactor it. Given that we're doing solving by completing the square, you may as well just complete the square on this part. Because we know we're just going to like add 6 to both sides or whatever. So you could start by subtracting 12 if you wanted to. You would not have to. All right, I'm going to be quiet for a minute and let you try this one.